Hello again. So in this video, we're going to look at a little bit more information about those single replacement reactions because they don't always happen. One of the examples that we looked at is you put potassium metal in water and it explodes, forms hydrogen gas. But that doesn't happen with every metal in water, right? You have at home, you have, maybe copper pots or, you have silver jewelry or gold jewelry that, it doesn't explode when it touches water. So why is it that sometimes a single replacement reaction will happen and sometimes it won't? What's the defining characteristic of that? And it's something that's called the activity series. The activity series is a table. You have it on your notes. It will be given to you on the test. So this is not something that you need to memorize at all. But the activity series tells you which metals are more reactive than other metals. And so at the top of the table, you'll see a lot of the alkaline metals, lithium and potassium. And then comes the alkaline earth metals. And then you get a whole bunch of transition metals in there. And then remember we said hydrogen can sometimes behave like a metal. There's hydrogen behaving like a metal again, right underneath lead. And then we have metals, copper, silver, gold, those metals that are sometimes referred to as the coinage metals, like literally making coins. Those metals they don't react with water. They don't react with the water, and therefore they're useful in making a lot of just compound stuff out of, not really compounds out of, just stuff out of. So this activity series tells us basically which metals are most reactive and which ones are least reactive. And when we mean by reactive, we mean which ones are most willing to give up their electrons, because that's actually how these metals behave in these single replacement reactions. Lithium, very willing to give up its electron. Gold, very unwilling to give up its electrons. So how do we use this? Basically, you need to remember alone above. That's the question you're going to be asking yourself. When you look at a single replacement reaction, you identify which element is alone, meaning by itself, not in the compound. And then you ask yourself, is it above the other element that it's trying to replace? Remember, metals replace metals. We also have a situation where nonmetals can replace nonmetals. We looked at that. The activity series for the nonmetals is as they're listed on the periodic table. So fluorine, chlorine, bromine, iodine. So I'm not going to give you that because you have that if you have the periodic table, but still that same alone above. And then there's just some more information down here about hydrogen. Hydrogen, so when we react a metal with water, sometimes it reacts, sometimes it doesn't react. You do not need to know that. I'm going to tell you that basically every time hydrogen is reacting, you can just do alone above and that's fine. But metals from lithium to sodium, so you can see those first couple of them, will replace hydrogen from acid and water. So it doesn't matter what hydrogen is in. If it's hydrogen from acid or hydrogen in water, it will react. But then after sodium, so here's sodium, from sodium on down, the hydrogen has to be part of an acid in order to react. And when metals replace hydrogen, remember it forms elemental hydrogen gas, H2. That's really important. So let's look and see how this actually works. Okay, so predict the products, we predict whether it's going to happen, and then if it reacts, what are the products? So again, alone, above. That's what I'm asking myself. So the question is aluminum above hydrogen? So then you go look back at the table, and is aluminum above hydrogen? And it is. So that means a reaction will occur. So that means aluminum will boot out hydrogen and hydrogen will be by itself. Now you need to remember two things. When hydrogen's by itself, that means H2. And then what's the new compound that's formed? Well, that would be aluminum and chlorine. And you have to use your ionic charges in order to make that compound. You can't just say AlCl. You have to remember that aluminum will form a 3+ ion and chlorine is a 1- ion. So the products will be, AlCl3. So those are the products. Then you balance. So you have to predict the products first and then balance. And don't try to do both at the same time because you will get it wrong. I noticed that the hydrogen, let's see, I'm going to, because the hydrogen is 2 on the right side and chlorine is 3 on the right side, and they need to have the same coefficient on the left-hand side. That's the way I know I'm going to have to make them both 6. If I put a 6 here, then how do I get 6 hydrogen? Put a 3 here. How do I get 6 chlorine? Put a 2 here and then put a 2 here. Okay. Alone, above. Is copper above zinc? Copper is a coinage metal. It is not above zinc. So the answer is no reaction. That's all you need to write. Is potassium above hydrogen? It is. And this is one of those cases where rewrite hydrogen as HOH. Okay? It's a good little trick. So potassium boots out hydrogen. Hydrogen is all by itself. When hydrogen is all by itself, it's H2. And then what are the other two ions? Well, potassium forms a 1+ ion. Hydroxide is a 1- ion. So it will be KOH. And now, we did this once before. Think about this hydrogen as being this hydrogen and hydroxide as being hydroxide and balance it that way. And then you go, okay, I need 2 pink hydrogens, I need 2 hydroxides and 2 potassiums. Is chromium above lead? Chromium is above lead, so this will react. Chromium will boot out lead. Lead will be by itself, and when lead's all by itself, it's just Pb. And then I have to think, what ions will form? So what ion, think about how we did this in the first one. Aluminum always forms a 3+ ion. Potassium always forms a 1+ ion. But chromium is a transition metal. It will form multiple different ions. So how do you know which one it will form? You just go back and look. It tells you which one it will form right on the activity series. Okay, so then it will be chromium 3+ and chloride 1-, or CrCl3. And then you have to go back and balance them. This is, again, chlorine is 2 on one side, 3 on the other. So make them both 6 and then balance out the metals that way. And the last one is a nonmetal replacing a nonmetal. So what you're asking yourself now is fluorine above bromine. And it is, because the activity series for the nonmetals is the periodic table. So remember, fluorine boots out the bromine. Hydrogen will combine with fluorine and bromine will be all by itself. And of course, to balance that, you put a 2 in front of those two. So that is the basics for how to predict whether a single replacement reaction, this is only for single replacement, whether a single replacement reaction will take place. And remember, the most important piece is you ask yourself alone above, and then once you figure out whether it will work or not, you predict the products by looking at the charges. What charge will the one that is alone, what charge will that form? That will actually make even more sense when we look at our next video, which is into even more detail about these single replacement reactions. And we're finally going to talk about what does oxidized and reduced mean.